Hello, my name is Desmond Edagisi, and you are welcome to Maths class today. Today we'll be looking at a very interesting topic, finding the logarithm of numbers less than 1 but greater than 0. Let's go on into our class. Now let's do a quick recap of what we learned in SS1. In SS1, we learned that the typical logarithm number is divided in two parts. We have the integer, which is also known as the characteristic. Then we have a decimal point that separates our other part, which is the fractional part, also known as the mantissa. So our decimal point is the dividing factor between the integer and the fractional part. We said to get the logarithm of a number greater than 1, we would take 3 steps. In the first step, we would find our characteristic or integer. Next, we also find our mantissa by looking it up from the logarithm table, of course. Then we'll combine both the characteristic and the mantissa to get our log number. Let's take a typical example. If we're asked to find the logarithm of 52.38, again, first we'll find our characteristic. To do this, we said in our class that we'll simply subtract 1 from the number of digits in the integral part of our given number. If you see, we have 2 digits here, so that would give us 2 minus 1. And it means that the characteristic of our logarithm number would be 1. Notice that it is positive. Next, we'll find our mantissa. Of course, this is looked up from the logarithm table. So if we look up our mantissa with the number string 5238 from the logarithm table, we would have 7192. So we simply combine our characteristic and the mantissa to get 1.7192. And that's the logarithm number of our given number 52.38. So in SS1, we learned how to find the logarithm of numbers greater than 1. Let's see how we can find the logarithm of numbers less than 1 but equal to 0. Remember, to find the logarithm of numbers greater than 1, we simply subtracted 1 from the number of digits in our integral part. And we said it was positive. Well, the opposite is the case for numbers less than 1. The characteristic or the integer of the logarithm of a positive number less than 1 is negative. And it is written as a bar. It is also numerically greater by 1 than the number of zeros between the decimal sign and the first significant figure of our given number. Let's go into our class and then we'll see exactly what we mean. Let's take a typical example. We've been given this number 0.5482. To get the characteristic of 0.5842, we'll simply check to see the number of zeros between our decimal point and the first significant figure, which we have as 5. Notice we have no 0 between both points. So we say we have 0 number of zeros between the decimal point and the first significant figure. And we simply add 1 to that. And that would give us 1. But again, we said it is negative. And the negative sign is annotated with a bar. So we have a bar over our 1. And hence we have our characteristic or our integer as bar 1. Let's take another example. Again, if we're given 0.05842 and we need to find the characteristic of this number, again, we'll quickly do a quick search to find the number of zeros between the decimal point and the first significant figure, which is 5. So we have 1, 0. And we put down 1 plus 1. And that would give us, again, 2. Again, we said for numbers that are less than 1, the characteristic of the logarithm number is negative. And that negative value is annotated with a bar. So we have bar 2 as our characteristic. Let's take another example. If we're also asked to find the characteristic of this given number, which is 0.005842. To do this again, we'll quickly count the number of zeros between the decimal point and the first significant figure, which is 5. And we have 2 zeros. So we have 2 here plus 1. And that would give us 3. Again, we said it's negative and it's annotated with a bar. So we have bar 3 as our characteristic. Let's go on. In the course of finding the logarithm of a number, remember the 3 steps we talked about earlier? First, we find our integer or our characteristic. Next, we find the mantissa, which is the fractional part. And then we combine both to get our logarithm number. So far, we've learned how to find the characteristic of a number less than 1. Of course, in our earlier classes, we've learned how to use the logarithm table to find our mantissa. The same thing we learned in our earlier classes in SS1 is basically the same thing. So once again, we look up our mantissa from the logarithm table. Of course, we know that the logarithm table is broken into rows and columns. And we have a difference column. The rows have a list of numbers 10 to 99 along with their mantissa value. The mantissa of the first 2 digits of our given number is traced on the row, while the numbered columns are traced to intercept the trace of the first 2 digits on the row. The 3rd digit of our number is traced here. The column labeled difference is used to trace the mantissa of our last digits. All the values accrued from all our traces here are, of course, added up to give us our mantissa. Let's take a look at what a typical logarithm table looks like. Once again, we've learned that it has values from 10 to 99, along with their mantissa values, as you can see. We have columns also that are numbered, and we have the difference column where we look up our last digits. Let's take a typical example to find the logarithm of numbers that are less than 1. If we were asked to find the logarithm of 0.05842, once again, we'll take our first step to find the integral part, which we know as the characteristic. To do that, again, we'll quickly do a count of the number of zeros between the decimal points and the first significant figure. At a quick glance, we see that we have just 1 0. So we have 1 plus 1 to give us 2. And of course, we said it's negative, and that negative sign is annotated with a bar. So we have bar 2. It means that our logarithm number at the end of the day would be bar 2 point a certain fractional number. That fractional number, of course, we said we simply look it up from the logarithm table. Let's go ahead to do that. So, to find the mantissa part, we'll simply again go to our logarithm table and do a quick search. If we do that, we would search on the row 58 and trace it down to the 3rd number on our number string, which is 4. 4 would look up from the column 4 and trace down to meet our row 58. At that point, we would have a value 7664. The last digit on our number string is what? 2. We look 2 up under the difference column of our table. If we trace that down, we would have a value 1. So we'll simply add up our values here, which is 7664, and our values here, which is 1, to get 7665. This is our mantissa value. So we'll simply come back here. Again, that's what we get, 7665. So we'll simply add up our characteristic, which we got earlier as bar 2, and then we'll combine that with our mantissa. And this is the logarithm of our given number 0.05842. It's quite simple. Let's take another typical example. Let's go on and take another typical example. If we are asked to use the logarithm table to find the logarithm of 0.047, there are two quick ways to find the characteristic of the logarithm of numbers. One of the ways we've already looked at, which is simply to do a count of the number of zeros in our given number and to add 1 to it. Of course, it's negative, which is annotated with a bar above our number. Another way is to quickly write out our given number in a standard form. And at the end, we'll get a power of which our base 10 is raised to. That power is an indicator of our characteristic. If, for instance, we quickly write 0.047 in its standard form, we would have 4.7 times 10 raised to the power minus 2. So we can quickly know that our characteristic here would be bar 2. Let's go on. Now we have the standard form of our given value as 4.7 times 10 raised to the power minus 2. Let's also go ahead to express 4.7 in its index form with a base 10. So we have similar bases to compare. So to get this, we'd have 4.7 as 10 raised to a certain number. That number is a power that is the logarithm of 4.7. So to find the logarithm of 4.7, of course, we know what to do. We simply go to our logarithm table and quickly look it up. Let's do that quickly. So we have 47 as our number string. There is no other number after 47, so we simply look it up under the column 0. So 47 on our row under column 0 would give us a value 6721. So we have our x here as 6721. 0 point. Since our integer here is 4, of course that's 1 digit minus 1, that would give us 0. So we have 0.6721, which is what we have here. So now we have similar bases. And using the laws of indices, which we learned earlier in our class, we'll simply add up our powers. We'll simply have 10 raised to the power 0.6721 plus minus 2. Of course, if we brought this forward, we'd have minus 2 plus this. And the addition of this would give us minus 2.6721. Of course, the minus, which is our negative sign, is annotated for our purpose here as a bar. And that would give us bar 2.6721. So the logarithm of 0.047 is simply bar 2.6721. Let's take another example. Let's take an example. If we're asked to use the logarithm table to find the logarithm of 0.0084, quickly what we've learned, of course, we'll quickly do a count of the number of zeros between our decimal points and the first significant figures. If we did a count, we'd have 1, 0, 2, 0. So we have 2, 0 plus 1, which would give us 3. Again, it's negative, and that negativity is annotated with a bar. So we have bar 3 as our characteristic. Now, to get the fractional part, which is our mantissa, we'll simply look up our number string here, which is 84, using the logarithm table. Let's quickly do that. So we have 84 under column 0. And of course, that would give us a value 9243. So we'll simply add up our characteristic and our given value from the logarithm table, which is 9243, to become bar 3.9243. Let's take a look at another example quickly. If we're asked to use the logarithm table to find the logarithm of 0.00002514, we'll simply again quickly do a count of the number of zeros between our decimal point and the first significant figure. We have 4 zeros. So we add 1 to that, and that will give us 5. Again, we said the characteristic is negative and is annotated with a bar. So we have bar 5 as our characteristic. To get our second step, we'll simply find the mantissa part, which is the fractional part, 2514 from the logarithm table. Let's do that. So we have 25, which is the first two digits on our number string. We trace it on the row to intercept the next digit on our number string, which is 1. If we look that up from our column 1 and traced it down, we'll have an intercept at this point to give us a value 3997. If we continue to trace and trace the last digit, which is 4, under the difference column, if we find that out from our column 4, to intercept our row, would have a value 7. So we'll simply add up that value, and this would give us 4004. So we have 4004 as our mantissa. So once again, we simply combine our characteristic and mantissa to give us bar 5.4004. Now let's do some exercises. Let's see how much we've understood the principles we've learned so far. If we are asked to find the logarithm of 0.03862, the first step, can you remember? We said we'll count the number of zeros, right? Between the decimal point and the first significant figure. How many zeros do we have there? We have 1 0. So we add 1 to the one that we have, and that would give us 2. Again, we said it is negative and it is annotated with a bar. So we have bar 2. Second step. We said we'll find the mantissa, which is the fractional part. And how do we do that? We simply look up our number string, which is 3862, from the logarithm table. Correct? Let's go and do that quickly. So we have 38 as our first two digits. We look that up on the row, 38. Trace it down to the next digit, which is 6. 6 is looked up from our column here, column 6. And it intercepts our row at this point. This point would have this value, 5866. The last digit on our number string is what? 2. 2 is looked up under the difference column. And that intercepts our row to give us a value what? 2. So we simply add up our values and would have 8. So we have 5868 as our mantissa. So what do? We simply combine our characteristic, which we have earlier, with the mantissa that we got to get bar 2.5868. And this is our logarithm. Let's take a look at another typical example. If you are asked to find the logarithm of 0.000197, we would simply again go through our steps. The first step would be to find the number of zeros in our given number that is between the decimal point and the first significant figure. We'll have 3 zeros. And we'll simply add 1 to give us 4. We said the 4 is negative and it is annotated with a bar over our number 4. So we have bar 4 as the characteristic of the logarithm of our given number. The second step is to find the fractional part of our logarithm. To do that, we'll simply look up our number string here, which is 197, from the logarithm table. Let's quickly do that. So we have 19 as the first two digits of our given number string. We look that up on row 19. Trace it down to the next number on our number string, which is 7. 7 is looked up from our column here and trace down to intercept our row at this point. That would give us the value 2945. So we have our mantissa as 2945. It therefore means that our logarithm number will be a combination of the characteristic and the mantissa that we just got. And that would give us bar 4.2945. And that's our final answer. In summary, we've learned today that the characteristic of the logarithm of a positive number less than 1 is negative. And we learned that the negative sign is annotated on the number with a bar. So instead of writing, for instance, -2, we write bar 2. We also learned that the characteristic is numerically greater by 1 than the number of zeros between the decimal sign and the first significant figure of our given number. To find the mantissa part, we simply look that part up from the logarithm number. The logarithm of the number that we seek for is simply the combination of the characteristic that we've gotten earlier and the mantissa part that is looked up from the logarithm number. We've come to the end of our class for today. It has been a great pleasure for me taking you in this class, and I definitely look forward to seeing you in our next class, where we'll be doing exercises by using logarithm in calculations. Till then, it's bye for now.